This is Pythagoras' Theorem 1. This is the introductory video to Pythagoras' Theorem. Pythagoras' Theorem is a famous theorem that is on the Leaving Certificate every single year. This video is going to go through some of the basic questions that you might see with Pythagoras' Theorem. Pythagoras' Theorem 2 is the second video. That's going to go through, I suppose, real life examples of where we would see Pythagoras' Theorem. Now, if we were in class as normal, we would be looking at how Pythagoras' theorem came about, and how he came up with the theorem himself, and how it works every single time. However, on a video, that is a little bit difficult to describe, so we're not going to go into too much detail about how it came about. You should also be okay with Pythagoras' theorem. It's a theorem that you saw when you were in second or third year, and it's one that would have been on the junior cycle exam too. So on page 16 in the formula and tables booklet, you'll see this diagram here, which you can see in the middle of the page. So we have a triangle. Now the key thing is Pythagoras' theorem will only work with a right angle triangle. And to make sure you know what a right angle triangle is an angle that has 90 degrees, and that is always interpreted with this square-like looking part of the triangle here. So a 90-degree angle. So a right angle triangle has 90 degrees within it. And what Pythagoras says for a right angle triangle is that the longest side, and if you square the longest side, that's going to be equal to the other two sides. So in this case, B and A squared. So the longest side squared is equal to the other two sides squared. So some questions do not label the sides of a right angle triangles with the letter A, B, and C, making the formula on page 16 in the formula tables booklet a little bit confusing. So I think it's easier to remember the formula in words. So the longest side squared is equal to the other side squared plus the other side squared. So the longest side, just so you're aware, is always going to be opposite the right angle. So in every single triangle, the longest side is always opposite the right angle. Now on the online platform, I have uploaded a worksheet which is getting you to identify the longest side of a triangle. If you would like, you can try that before you try some of these questions to make sure you're comfortable and understanding which is the longest side of a triangle in a right angle triangle. Also, with the longest side of a triangle, we always call it the hypotenuse. So the hypotenuse is always the longest side. So if you have Pythagoras' theorem, which is c squared is equal to a squared plus b squared, c is always going to be the hypotenuse. Now, so the best way to get an example of what's going on, or to be more clear about how to answer questions like this, is for me to show you a few examples. So in question 2.1, it's going to ask you to find the length of x. So the key thing to do with this every single time is to always write out Pythagoras' theorem. And Pythagoras' theorem is c squared is equal to a squared plus b squared. Then what you should do is you should label the sides. So here we have the hypotenuse, which is the longest side, which is x, and that's always opposite the right angle. Then it doesn't really matter which what you label the other two sides. So I'm going to label 3a and I'm going to label 4b. You could have labeled 4a and you could have labeled 3b. It doesn't matter. The main thing that matters in this is you always label the longest side, which is opposite the right angle, as the side that's going to be by itself, which is c. So then this becomes x squared, and then that's equal to a squared, which is 3 squared, plus b squared, which is 4 squared. Now, so we have 3 squared, which is going to give us 9, and 4 squared, which is going to give us 16. So when we add them together, we're going to get 25. Now we have x squared is equal to 25. We need to figure out what x is equal to, so we need to get the square root of both sides. The square root of 25 is 5. So then here we have that the length of x is 5 units. In question 2.2, it asks us to find the length of y. Now, The main thing about this is to make sure that at the start of every single question you write down Pythagoras' theorem. So we have here c squared is equal to a squared plus b squared. Bearing in mind that we have c is the longest side. Now we know that the longest side is called the hypotenuse. And we also know that the longest side is opposite the right angle. So the right angle is here. The side opposite the right angle is 13. So we have 13 squared is equal to the other side. So label this as C. Then we can label this as A, or we could label this as A, but we have B here. So then this is going to become y squared plus 12 squared. So 13 squared is going to give us 169. That's going to be equal to y squared, and then 12 squared is 144. So we have to get the y on the side by itself. So I'm going to take 144 from both sides. From 169, take 144, we're going to be left with 25, and that's going to be equal to y squared. Now we want y, we don't want y squared, so to get y we have to get the square root of 25, and y then is going to be 5 units. Now sometimes we're asked to write our answer in surd form. Surd form is just another phrase for square root, so it just means there'll be a square root in our answer. The main thing about this is when there is a square root in our answer, you don't press the SD or the change button on your calculator to change it into a decimal point. They want it as a square root. And I can show you again with an example. So we'll hopefully be perfect with all of the Pythagoras theorems type questions once we have these two videos done. So again, with this question, we're finding z, but because it is a Pythagoras theorem question, we're always going to write down the Pythagoras theorem formula. Bearing in mind that for using Pythagoras theorem, it has to be a right angle triangle. There will be times when we're not sure what we will have to do to solve the question, and we'll go through that when we have other sections of trigonometry done. But obviously for the questions we're going to be doing that accompany this video, it's all going to be Pythagoras' theorem. Now, so for Pythagoras' theorem, we have to label the sides. So C is the hypotenuse, which is also the longest side, and the longest side is always opposite the right angle. So in this one here, C is going to be 7, A is going to be 4, and Z will have as B. So what we'll get here is we'll get 7 squared is equal to 4 squared plus Z squared. So 7 squared is 49, 4 squared is 16, and that's plus Z squared. So again, we're going to take 16 from both sides because we want the x squared by itself. 49 take 16 is 33, and then that's going to be equal to z squared. Z then is going to be equal to the square root of 33. Now for this, to double check to make sure you have the square root in its lowest form, if you just type the square root into your calculator, you'll be able to see whether it can be broken down. But when you type a square root of 33 into your calculator, the answer you will get is square root 33. So it can be broken down into a simpler square root, so we leave it as square root 33. The next question in this booklet tells us that ABC is an isosceles triangle. So bearing in mind that an isosceles triangle could be a right angle triangle, because an isosceles triangle is a triangle that has two sides and two angles that are the same. So it tells us here that AC, so the length of this line on the left hand side of the triangle, is equal to BC, which is the bottom of the triangle. It tells us that AB is square root 72, and it tells us that the angle ACB is 90 degrees, and it wants us to find BC. Now, in maths, when we need to find something, we always label it as X. So in this question, I'm going to label BC as X. But BC is also the same length as AC. Now, I know that looking at this triangle, they don't look the same length, but they have told us that they're the same length, so we must label them as the same thing. So we're trying to find BC. Now, when we're trying to find that, we are going to use Pythagoras' theorem. So we have C squared is equal to A squared plus b squared. Again, we might not initially know that this is a Pythagoras theorem question, but obviously because we're watching a video on Pythagoras theorem, we're going to use Pythagoras theorem. However, when we get into the more complex questions, there's a method we can follow to figure out exactly how to solve a problem with a triangle. So Pythagoras theorem again, so C is the longest side, and the longest side is always opposite the right angle. So I'm going to label this as C, and then I can label the other sides as A or B, doesn't matter which one. So this one here, we have the square root of 72, and that's equal to x squared plus x squared. So the square root of 72, when we square that, it's going to give us 72. And then we also have here, so x squared plus x squared, that's the same as an apple plus an apple, so we get 2 apples. So here it's going to be 2x squared. So then to get the x squared by itself, we'll divide both sides by 2. 72 divided by 2 is going to give us 36, so 36 is equal to x squared. We then have x squared is, we need to find what x is. So to find what x is, we square root both sides. The square root of 36 is 6, so 6 is equal to x. So then the length of BC is 6, and the length of AC is also 6. Bearing in mind that because it's an isosceles triangle, that the angle here and the angle here are also going to be equal. And you'd be able to work that out too, but I'm not going to work it out now because that's not what the question is asking us to do. The final question we're going to look at in this video is question 2.5. So here it tells us that the lengths of the sides of a right angle triangle are shown in the diagram. So the first thing it says is, using the theorem of Pythagoras, write down an equation in terms of x. And what we have here is we have that Pythagoras theorem is c squared is equal to a squared plus b squared. Now, part I says using Pythagoras theorem, so I'm going to write out Pythagoras theorem again. So c squared is equal to a squared plus b squared. We know that c is the longest side, and it's also the side opposite the right angle. So in this one, it's going to be 2x plus 2, and that's c. And then it doesn't matter what the other sides are, one has to be a and the other has to be b. So we just fill it out then, so it becomes 2x plus 2 squared is equal to x plus 1 squared plus x plus 2 squared. Now that's part I completely finished because we've written an equation in terms of x using Pythagoras' theorem. The second part here wants us to solve this equation. Now, to solve this equation, we need to get rid of the brackets to start, so the 2x plus 2 squared. A lot of people do a lot of illegal things next, and I'm just going to show you exactly what they do so you don't make the same mistake. So what we can see is 2x plus 2 squared. What would happen is people would square the 2x, which would be 4x squared, and then they would square the 2, which would be 4. And they'd leave it like that. Now this is highly illegal, you cannot do it, it's not allowed. So, and just to kind of show you what I mean, I'm just going to kind of rub this part out here. And say for example I had 3 squared, that means 3 times 3. If I had x squared, that means x times x. And for example, if I had 1 plus x, that means 1 plus x times 1 plus x. So we need to make sure we're always writing it out in that way too. Now that's just an aside to show you what you could do if you made a mistake or a place where people fall down. I'm going to go back here now and I'm going to fill this in properly. So this is going to become 2x plus 2 times 2x plus 2. That's going to be equal to x plus 1 times x plus 1 plus x plus 2 times x plus 2. There's 2 ways to complete the next step. So we'd have our arrows, which would mean we would have 2x times 2x, 2x times 2, 2 times 2x, and 2 times 2. I find that way can be a little bit messy sometimes, so I just like to write out exactly what we're going to be doing. So we'll have 2x, and we're going to multiply that by 2x plus 2, and we'd have plus 2, and that's going to be by 2x plus 2. That's equal to, so x times x plus 1, and plus 1 times x plus 1 plus x times x plus 2 plus 2x plus 2. Yeah, and then the last thing we have to do is just multiply these out the bracket. So there's two ways. If you're happy enough doing it with the arrows, making sure that you're not going to make any mistakes, that's perfect. If you think that you will make a few mistakes, just write it out the next step just to make sure that it is going to be okay. So we're going to have here 2x times 2x, which is going to be 4x squared plus 4x plus 4x plus 4. That's going to be equal to x squared plus x plus 1 plus x squared plus 2x plus 2x plus 4. So now we've multiplied out all the brackets. I'm just going to get the like terms here now. So in this one we have 4x squared on the left, we have a 4x and a 4x, and then we have the 4. On the right hand side we have the x squared, we have an x, a 2x, a 2x, and we have a 1 and a 4. So I'm going to add the like terms on different sides, keep them separate for the moment. So this will stay as 4x squared, this will become plus 8x plus 4. On the right hand side then we have x squared plus x squared, 2x squared, x plus 2x, which is going to give us 6x, and then plus 1 plus 4, which is plus 5. So I'm going to bring everything over to the left hand side. So from both sides I'm going to minus 2x squared minus 6x minus 5. So we'll end up here with minus 2x squared minus 6x minus 5. So we're going to be left with 2x squared plus 2x minus 1 is equal to 0. Now, if you look back up at the question here, they give us a key point and one thing you need to be certain of when you're solving this question. So it says, solve this equation to find x correct to 2 decimal places. Now, we know when we have a quadratic, which we have here, there are two ways to solve it. The first way being the minus b formula, and the second way being our box method. And we spent loads of time making sure that we're comfortable with doing both. But every time it says correct 2 decimal places, that means x isn't going to be a whole number, so we have to use the minus b formula. So every time you see correct 2 decimal places or 3 decimal places or in third form or anything like that, you're always going to use your minus b formula. So making sure with your minus b formula always needs to be in the form ax plus bx plus c is equal to 0. So in this case, a is going to be 2, b is going to be 2 also, and c is going to be minus 1. So making sure we take down the minus b formula, it's on the cover of the formula tables booklet. We have minus b plus or minus the square root of b squared minus 4ac all over 2a. Now then, when we fill this in, it's going to be minus 2 plus or minus the square root of 2 squared minus 4 times 2 times minus 1. And all of that is over 2 times 2. So then you just type this into your calculator. We'll do the plus side first, and for the plus side you're going to get x is equal to 0.37. And for the negative side, you're going to get that x is equal to minus 1.37. So, solve the equation to find x correct to 2 decimal places. We have 2 values for x. The first value correct to 2 decimal places is 0.37, and the second value correct to 2 decimal places is minus 1.37. So that's that question done, and this is the first trigonometry video done, and the first introduction to Pythagoras' theorem video completed.